Hi, I'm Karishma.
And I'm Jacob, and Karishma will be talking to us today about isotopes.
What is an isotope? Every element is defined by the number of protons it has. For example, hydrogen has 1 proton, helium has 2, and carbon has 6. The number of protons is what unites all atoms of the same element. The number of electrons may vary among atoms of the same element, as may the number of neutrons. The number of electrons in a neutral atom is the same as the number of protons, and when the number of electrons is different, the atom is referred to as an ion. For example, here we have a hydrogen ion, which has 1 proton and no electrons, so it has a positive charge. In most elements, the number of protons and neutrons is also generally the same. Variations of the same element with a different number of neutrons are known as isotopes. An element can have a wide array of isotopes that are found in nature. For example, here we have 2 isotopes of helium, both of which are naturally occurring. In this isotope, we have 2 protons and 1 neutron, and here we have 2 protons and 2 neutrons. Stability of isotopes. The most stable isotopes of an element are generally ones that have more neutrons than protons. Protons are positively charged, and as we know, like charges repel. The neutrons act like glue between positively charged particles that would normally repel each other, allowing the nucleus to be more stable in its given state. If a nucleus is not stable, it often gives off particles in the form of radiation until it does become stable. This graph shows in the solid line the 1-to-1 ratio of neutrons to protons. The dots represent the most commonly found isotopes. As the number of protons increase, the isotopes with the most stable nuclei have a neutron-to-proton ratio of more than 1. Isotopes with fewer neutrons than protons would be depicted under the solid line, but they essentially never exist. These dots form what is called the nuclear belt of stability, representing the composition of the nuclei of the most stable isotopes. Average atomic mass. The number of protons of an element is known as the atomic number, and the number of neutrons plus protons is the atomic mass. The atomic mass, given under the element symbol in the periodic table, is actually a weighted average of all the isotopes of the element, taking into account the abundance of each isotope. The average atomic mass is usually closest to the most common isotope of that element. For example, carbon has 16 known isotopes, from carbon 18 to carbon 23. The 8 and the 23 represent the sum of the protons and the neutrons, and all isotopes of carbon have 6 protons. Carbon's average atomic mass, the one written on the periodic table, is about 12.01 atomic mass units. This number suggests that the most common isotope of carbon is carbon-12. Calculating average atomic mass based on the abundance of isotopes. We can calculate the average atomic mass of an element if we are given the masses of all the isotopes as well as the relative abundance of the isotopes. The term relative abundance refers to the percentage of all carbon atoms, in this case, that have a certain atomic mass. Although we mentioned earlier that carbon has 16 isotopes, the 3 naturally occurring ones are carbon-12, carbon-13, and carbon-14. Carbon-12 has 6 neutrons and 6 protons, carbon-13 has 7 neutrons and 6 protons, and carbon-14 has 6 protons and 8 neutrons. The relative abundance of carbon-12 is 98.9%, that of carbon-13 is 1.1%, and that of carbon-14 is less than 0.1%. To calculate the average atomic mass, we multiply each abundance by its coinciding atomic mass and add them all together. As a result, we get the average atomic mass to be about 12.025 atomic mass units. And this calculation is slightly off, as our relative abundances for carbon-13 and 14, or the relative abundances that we use in our calculation, are higher than they actually are in nature. Unstable isotopes. Isotopes may be unstable if their neutron to proton ratio does not fall within the nuclear belt of stability. When a nucleus is unstable, it gives off radiation in the form of either alpha, beta, or gamma rays, until the nucleus has decayed to a stable form. Carbon-14, for example, is an unstable isotope of carbon. We could assume that just looking at the relative abundance, which indicates that less than 0.1% of all carbon atoms have 8 neutrons. Carbon-14 atoms emit beta particles until a decay product is reached, which is nitrogen-14. Carbon-14 is typically found in organic matter, and because of its instability and natural radioactivity, it is often used in dating fossils, for example. In conclusion, isotopes are essentially versions of the same element, the distinguishing factor being the number of neutrons. The number of protons, however, must be constant from isotope to isotope. In atoms with fewer protons, a 1-to-1 ratio between neutrons and protons yields the most stable atom. In atoms with more protons, a higher ratio between neutrons and protons is more stable. The periodic table gives us the average atomic mass of each element, which is calculated based on all the isotopes of the element and their respective relative abundances. When isotopes are unstable, they are radioactive and emit radiation until they become stable. Here are some examples of isotopes. We have sodium-23 and sodium-24, hydrogen with 1 proton and 1 neutron, hydrogen with 1 proton and no neutron, and hydrogen with 1 proton and 2 neutrons. And we also have uranium, 238 and 235.